Thanks, Kier. First of all, I want to thank everybody for letting me be here today. This is not my first NewSpace conference. The first one I had was about 3 years ago, in which they asked, Jim, would you mind coming to our NewSpace conference? It was going to compare what's going on in old space and new space, and I was so excited about the potential of talking about all the new activities going on, etc. And so then I got off the plane and I saw a placard with my name at a wheelchair, and I realized I was supposed to be representing old space. And needless to say, I was a little bit distraught. Yes, there's a few more wrinkles, but I still thought I was kind of motivated about what was going on with NewSpace. And then one of the things that occurred to me was kind of a deja vu of my own experiences in the late 1990s, early 2000s, where we talked about something called the internet in the sky. We were going to blot out the sky with satellites. We had billionaires. We had new technology. We had companies called Teledesic, Ellipso, Iridium, which you've heard about now, Skybridge, Spaceways, numerous systems that were going to basically create the new space. They talked about a lot of different things relative to building multiple satellites, getting the cost down. Launch costs were dramatically lower. Does any of this sound a little bit familiar? So the question was, what happened? Why did that not work? Why is NewSpace now going to work? And so I started thinking more and more about what has transpired? What is going on that's different? What did we have to learn to be able to come into the, I'll say, a renaissance of a NewSpace 2.0? And by the way, I thought I was young back then. I was old back then compared to the people that are in this crowd. So one of the things that we did look at was that some of the fundamentals that we had were not technology. Technology was not the problem we had even in the early 2000s. Yes, there were some cost points relative to some terminals for ground terminals and other things that we quite didn't figure out. But the real issues were that we did not anticipate the business plan appropriately. We did not recognize what some of the potential alternatives were to space. That we thought that we didn't anticipate that GSM would be as global as it truly was from a terrestrial perspective. And we didn't realize how important it was to be on time to be at market, because frankly, it allowed the terrestrials to catch up. It allowed a lot of things, and the dollars and the price points went down and down and down. So there was a certain other mentality there that was effectively build it and we will come. It was a little bit more of a field of dreams type of an approach, that once this was up there, then it would be utilized. So what's different now? What's different now? What you're seeing is, besides the entrepreneurs here that were great, Chuck Beams, one of my friends, talked yesterday, the business potential, the incredible excitement in the venture capital community, etc. The things that I think are different now is that some of the tech giants, some of the customers that are actually building the infrastructure in space, it really is infrastructure. That they have actually a business case and a business need for that infrastructure. The recognition, for example, that 70% of the world is not covered by the internet. We're not covered with easy access to the internet. And it's not easy to lay out a lot of ground infrastructure to enable that to happen. And so when you're looking at trying to expose services, sales, marketing, etc., advertising to 70% of the market to open up for all of the tech giants, it's something that's extraordinarily appealing and something that's really something that has a business case associated with it. Because of all of that, NewSpace 2.0, as it's been called several times, has a significant opportunity, because not only is space is not the end all, space is the vehicle that enables other opportunities to happen on the ground. And once that thought process and mentality occurs, NewSpace can evolve. NewSpace will evolve. And NewSpace will cause some of the creativity that we're looking at right now. one of the things that that a lot of people start to think about more and more when they talk about new space, in fact, is that we talk about new space because space is cool. I mean, let's face it, it really is. You know, when I started in the business with my, you know, everybody's talking about, what it was, Chuck Beams, I think, was talking about yesterday, that you guys have your own computer in your hand right now. I think I started with an abacus. But even back then, when we started thinking about that, when I used to talk to everybody else about what they did for a living versus what I did for a living, and some of them were quite successful, made quite a bit of money, etc. There wasn't one person that I would have traded jobs with as far as the excitement of my business. Okay, I lied. I would have been a baseball player if I could have. But other than that, there is no business more exciting than space. But the key aspect when you're looking for venture capital, when you're looking for investments, when you're looking for actually improving your operations, is not space. It's what are you going to be doing? Are you a communications business? Are you an Earth observation business? Are you a business that provides processed capabilities to other customers? Because it's not what's up there. It's what you're bringing down and how it's going to be utilized that's going to determine whether new space is successful or not. And so it's absolutely essential. Now, what are the enablers that new space can do that allow that type of capability to be done more economically, which is what everybody was talking about yesterday. And so part of that whole key are some of the things, believe it or not, we learned in space, New Space 1.0. It was rate is critical. If you want to get the cost down, get the rate up. And so what you talked about, a lot of people talked about yesterday was, how do I build small satellites? How do I build more satellites? How do I get the cost down by using off-the-shelf capabilities? How do I recognize that I'm okay with a satellite being only 2 to 3 years old, and then I'm going to go to a new type of capability because of Moore's Law, because of the theory of microcosm? How do I enable this to happen? How do I make sure that the rate is there? How do I make sure that I'm constantly renewing my capabilities so that I'm not 2 generations behind consumer electronics? In the when Space 1.0 just collapsed, let's face it, it collapsed. Teledesic died. Iridium, although it's around now, the reason Iridium's around now is it went bankrupt and it was sold for less than cents on the dollar. And now the good news is it's been renewed. It's a highly successful business and looking like going forward. But it almost is an analogy of a really bygone era, the train business. When we were looking, when Amtrak and all of the train business for the United States was going forward, the reason it was successful when it finally occurred, it went bankrupt at first and people bought it at cents on the dollar. Now, I'm not telling you that's a strategy, but that's an approach that's going on. But what happened, though, is when all of these systems collapsed, the sky bridges, the ellipsos, the Astrolinks, the Teledesics, Globalstar's been renewed, but Globalstar was one of them as well, is that there was a hunkering down that occurred. The commercial boom had ended to a certain extent in space. And what happened was that the government started to go more and more conservative. And the reason I bring this up is that part of the elements, which is all everybody's been talking about right now, is assured access to space. And not only assured access to space, low-cost assured access to space. And there was a program called the Evolved Expendable Launch Vehicle Program that Lockheed Martin and Boeing were part of. The ELV program was to get the dollars per kilogram to orbit dramatically lower than it ever was before with the current launch vehicles that were available at the time. And it was. And to put things in perspective, the Delta IV heavy launch vehicle, which launches all the critical missions now for the U.S. government, the initial sale price plan for that was roughly about $120 million. Put that in perspective, that's $5,500 per kilogram into orbit, into GTO. SpaceX, which everybody thinks is, by the way, is a phenomenal success. It is, by the way, kind of a news flash, is probably the only NewSpace business that actually is making money operationally. I know people like to argue that, but the fact is, it probably is. Most of the NewSpace businesses either make money through an IPO or when they sell the business. I don't want to disillusion everybody, but hopefully we'll get that going, so it'll be an operational key as well. But the fact of all of that was SpaceX dollars per kilogram is $10,000 per kilogram. So it's not like we've suddenly gone through this major breakthrough. Now, what SpaceX has been able to do is, because of rate and because of ways they figured out how to be totally vertically integrated, they look like they have a potentially an opportunity to be sustainable at $10,000 per kilogram, which clearly the Delta IV program, when it went from 40 potential launches per year to about 4, couldn't maintain. But again, I want to make sure that everybody understands how important rate is in the ability for the execution of new space. Again, lots of satellites coming through, getting the learning curve, being able to get the critical technologies, et cetera, going forward. It's absolutely essential. Then the other aspect is, how do we be able to capture the utilization of multiple different technologies? How are we able to utilize different techniques, whether let's go into Earth observation for a second, where we're looking at things like, do we do multispectral, hyperspectral imaging, Earth observation? How do we take that kind of capability and then fuse all that data to be able to provide that product? And how do we actually then, are we able to use Earth observation and Earth sensing to be able to be a business that, by the way, this is something you ought to write down. It's really, really critical. If business has to make money. And because of that, your business cases have to close. So how is that key technology going to enable a product that actually somebody's going to buy? Recently at a conference where on entrepreneurship, and part of that entrepreneurship discussion was really where the things fail relative to entrepreneurial business, exclusive of space, but inclusive of space as well. And the biggest issue that every one of them had was they had really cool ideas. I mean, I've heard some incredibly cool ideas. I'm going to squeeze water out of an asteroid, and then I'm going to be able to make that, be able to determine how we can water the different places in the world from an agriculture perspective to be more efficient than ever. Awesome. Not clear how we're going to make a lot of money on that, but it's awesome. But the thing I want to talk about, though, is that do you really have customers? Are there really customers that are interested in your product? Are there customers that are really willing to commit to your product even before you created that product? Have you gone to enough customers to enable you to be confident that your business is going to work? Have you provided them it doesn't have to be a prototype. Have you brought them anything with the minimum amount of salient features to enable you to be able to show that to a customer, and that customer can comment whether, yes, this is the capability I want, or no, this is not what I want, I need X, Y, and Z, and so it enables you to pivot to enable you to be able to create your product better, so that when you finally field your product has committed customers that enable your business plan to close. This sounds so mundane when we've been talking about squeezing water out of asteroids, but the fact of the matter is that it all comes down to, how do we make money? And that is part of the key, is you've got to have the business discipline besides the key technologies for the space. And I don't like to bring it up, it sounds pedantic. The fact of the matter is, for every one of these groups to be successful, homework is not just on the technology side, homework is on the business side as well. With that said, there are some phenomenal things going on. Jason Andrews, who was here yesterday, I had the opportunity to go to his facility last night, and since I used to run commercial satellite business at Boeing, we had a huge factory with large, monstrous satellites, and incredible complexity and logistics, etc. And it was really cool. It still is really cool. But I go to his facility, and he's building very capable satellites in a very small area, but it's very efficient, very effective, using costs off-the-shelf parts, and he's going to be providing a very, very valuable Earth observation system. And so there are multiple ways to skin a cat. And the approaches that we're looking at relative to economics, if you looked at some of the systems that a large aerospace company build versus what we're looking at from an entrepreneurial perspective, the mindset is spectacularly different. Yet the products and the opportunities are relatively the same. There are certain needs that drive the things that you're going to see in a large aerospace company. There are things that you're looking at from a small company too that's trying to be very entrepreneurial and trying to get product very rapidly into the marketplace. In fact, a lot of that aerospace activity and a lot of the things that are driving that we call old space were really driven, kind of frankly, out of what I come back to Space 1.0. And the reason that what happened with Space 1.0, commercial collapsed. And so what happened was, okay, the economics of space to a large extent became more and more government driven. The government aspects that occurred were really a matter of I have to have this asset up into space. My cost of my launch vehicle is so expensive that I want to put the most stuff on my satellite I possibly can to get that economics of that launch through. And so therefore you started seeing these large satellites that had incredible complexity to them because the cost of launch was so much and now the satellites were so much that now I had to test the living tar out of these things because I couldn't have them fail. Failure became unacceptable. When failure becomes unacceptable, costs go dramatically up, and hence you see rate go down, and it becomes this vicious cycle that caused this problem with space, where it became virtually not an area where we could do this type of entrepreneurial stuff that we're talking about right now with NewSpace. With that said, the success factors have been spectacular. EEOV, although obviously a lot more expensive from a launch vehicle perspective than anybody in the room wants to admit because of the costs of things going to orbit for commercial applications, it's 100% successful. And so mission success, when you're talking about things that absolutely have to be on orbit for national mission requirements, the model works great. It's expensive, but it works great. There are things that we're doing right now that are maybe counter even intuitive to some of the lower cost space applications, such as driving more mission quality into some of the launch vehicles, trying to get away from Russian needs, going to establish U.S. launch propulsion systems to be able to assure access to space, not necessarily reduce costs to space, although there are opportunities to do that, because of national mission needs. And the reason I bring up all this government stuff is 2/3 of all of the missions that are done in space now are still government. And so the government happens to be a large economic factor associated with the overall space economy. And so until that changes, a lot of the requirements and things that are driven in space are driven from government needs. Now, how do we evolve away from that? Things that SpaceX are doing are actually kind of revolutionary in the fact that SpaceX has effectively said, I have a product, government, and if you want to use my product, that's great, but I'm not altering the product without you absolutely, having to pay for that, because my customer, my main customers, my commercial customers, these are the economics they want. They're accepting of the reliability that I have with my vehicle. So we're going to be seeing, and you guys got to pay attention to this, is there's going to be a struggle between the government and commercial space applications as far as the dynamics are concerned. I think they're healthy though, because where the entrepreneurship provides economics, new ideas, new concepts of how to use commercial off the shelf, get the costs down, look at the business case. The government provides some disciplines that really are required for space, because it's hard. Space is really hard, and to be successful, there are certain disciplines that have to be imposed on that. And there's becoming, and you're going to see this more and more, there's a blending now of where you're seeing the old space regimes, the Lockheeds, the Boeings, the Northrop Grumman's, et cetera, are moving some of their activities more and more to what I'll call the new space regime. I think you're seeing some of the things from the new space regime moving towards what's going on relative to the old space regime. And so what you're seeing is this kind of collision of the two groups, trying to get the best, not the worst, of both cases, and seeing it and making sure that this happens going forward for a NewSpace applications. So, you know, I'll give an example. We're a microcosm of it, but Aerojet Rocketdyne is actually doing that as well. Not only are we building the traditional Artis 25 engines for space launch systems for manned applications that are derivatives of space shuttle main engines, but as Fred Wilson talked about yesterday, we're doing electric propulsion. We're looking at nuclear thermal propulsion. We're looking at clean propellants, green propellants. We've caused relationships with some of the, we're working with a lot of the entrepreneurial groups is trying to bring that to fruition. So again, you're seeing kernels of NewSpace and OldSpace emerging together and coming together. So I think we're coming out of the dark ages. I think that the NewSpace 2.0 is going to be successful. But 2.0 is successful if we really do the things that we need to do. Embrace the technologies of the consumers. Embrace the technology of commercial off the shelf. Embrace the entrepreneurship that's going to enable a lot of the things happen going forward. But be mindful of the understanding of the things that you've learned from lessons from government perspective. Be mindful of what you need to do from a business perspective. And when you do that type of thing, this could really open up space for all of the different things we wanted to do it. Not just communication, not just earth sensing, tourism. Open your mind to all of the different things. Because the bottom line is that space allows you that access, that ability to be able to provide capability around the world, open up new markets, enable you to be able to bring products that are going to be exciting, dramatic, and change the world even further than we ever thought. I'm fortunate enough to have been here working longer than 99% of you have been born. And I think my wheelchair is, by the way, out in the back. But I'm really excited about what's going on. It is a new frontier. It is a new way to look at business. It is a way to finally capture what you're going to be doing in space. And as a career, there's nothing better. I am really excited for all of you, and I'm excited for working in this industry, and I want to thank you for being patient with me while I muddle up here. Yeah. So questions, anybody?
Question? Okay. I've been following the progress of orbital debris for a long time. That's kind of the elephant in the room. I mean, we're talking about launching all these satellites and everything, and we could virtually turn it into a blender up there where low Earth orbit is unsurvivable. So what would your opinion be of a coalition for mitigation be formed and experimental satellites launched to capture different varieties of debris?
Well, I think it's a great question. So first of all, I mean, let's knock on wood here. The good news is that we have been incredibly fortunate in not having any conjunctions to date, or very few. And fortunately, as long as we don't have ASATs and other things going up there, there's a lot more control. The debris can be controllable, but the debris is getting larger and larger. And I've been asked this question several times, when I was at Boeing, they thought, well, do you think it's Boeing's obligation to be able to clean up the space? I think that a coalition here is the absolute right answer for it. It's an international coalition. Right. Because space is an international activity, and living in space, and in a very congested business that it's going to be in, is an international requirement. And extrapolating off what we did with the International Space Station, and extrapolating off these other things, this is an international requirement where I think that we need to have a coalition that is willing to go in there, look at the approaches to be able to collect the debris that's currently there that's an issue. And number two is cause regulations, et cetera, on how we exit the LEO orbits to enable us not to keep junk in space.
Right. Every mission should be planned to end without creating debris.
Exactly. And so that's part of the, that's a requirement. But that's a requirement and a desire to enable us to be able to use space.
Okay, thanks.
Sure.
We have a number of students in here representing Space 3.0 from the Aviation High School sitting in front. I think it would be useful for them to hear how you got where you are now, and what did you study, and what was your career path?
Mostly it was on bribery. My grandparents came from the Orkney Islands in Scotland in 1927. My granddad started at Douglas Aircraft in 1927, became a vice president of Douglas Aircraft in Long Beach. My dad was a fighter pilot, worked at Douglas Aircraft, Douglas Aircraft until 1990. I started as a summer hire at McDonnell Douglas in 2000 as a summer, no, 1979. At our dinner table, we talked about sports and we talked about space and we talked about aircraft. Actually, I was the bastard son because I went to space, not airplanes. But I loved it. I was pre-med for 2 years, and I decided that at that point, I was a summer hire. I loved engineering so much. Changed my major, became a materials engineer. Went to UCLA. I know I'm sorry, Seattle, but I'm not rooting for you guys. Okay. Went to UCLA, got my bachelor's and master's in materials engineering. I was fortunate enough to be able to be on multiple different programs. This was kind of a key thing, and by the way, it's happening in your area right now too, is that I was really young, and there were all these old people, and there was this chasm in between, and they had to give us responsibilities that they never thought they would. I mean, to give me responsibility as a 25-year-old or 23-year-old to do stuff that they must have been scared out of their minds. I was, but I thought it was kind of cool. So I was given a lot of responsibilities. I was given responsibilities not just to do materials engineering, but could I do things more? I was given, at the age of 26, I was given the ability to do all of the technology on the Evolved Expendable Launch Vehicle. I was responsible for that for McDonnell Douglas. I didn't know anything about avionics, but man, when you're suddenly responsible for it, you get to learn really quick. And that activities occurred. I got more and more responsibilities. For some reason, they liked me. Around 1990, this really you're asking me to do boring things, but about 1992, I went to the Antichrist USC and got my master's in business administration. Became more and more. Business cases became more and more important. Ran the first phase of the ELV program. Sold the first commercial Delta IV. Then, after getting into the Delta IV business and actually then running sales and marketing for both, actually believe it, Sea Launch and the Delta products, was fortunate enough to go into the satellite side of the equation. Was in the satellite business for 13 years, president of the commercial satellite business. Then ran all of the network and space strategy and business development, and then decided I wanted to do something a little bit different in a little bit smaller environment where I had a little bit more control. Believe it or not, even though you're a senior vice president at Boeing, sometimes there's a few more layers of management. And with Aerojet Rocketdyne, who has an enormous tradition relative to rocket engines and evolving the rocket engines, and something that I've always been excited about. I mean, there's something about rocket launch. There's nothing like it. And there's nothing like lighting a rocket engine and seeing it go. I mean, since when I was a kid doing Estes rockets, having the police come and talk to me a couple times, to now, there's nothing like it. It's a controlled explosion. How much cooler can it be? And we get paid for it. So that's what I've done, and I love the career.
Yeah, you made a few remarks about competitor SpaceX, and did you say that you think they're actually making a profit? Because nobody I talked to thinks they are, because the the head count is too high, the launch costs, what they're charging is not enough, and they've got so many other projects going on, like construction in Texas and Florida and Red Dragon. So can you comment a little bit on that?
Well, they're a private industry. I think you can debate one way or the other. I think there's probably people from SpaceX here that could clearly answer that much better than I. They have great government contracts. They've got a good commercial backlog. They've done some really creative things from a vertical integration perspective. I think one of the things that's very interesting about them is that even though there are there's always going to be some concerns about reliability when you have 9, 10 engines and you have even engine out capability. But the fact is, from a production perspective, every one of your launches, think about it, you're building 9 engines, so you're going down a learning curve. So yeah, whether they've made a full profit or not, they actually have at least a plan, and they have a backlog that seems to be pretty good.
Yeah, they just don't seem to be launching very well. They are now launching more. All right, thank you.
Sure.
Hi, Jim. Really interested to hear your comments about the mistakes and the learnings from the previous generation that you made.
Of course, I didn't make any of those mistakes.
Of course, no.
I'm just merely pointing out there were issues.
Well, I was going to say, you seem to have seen a lot of different places and pieces of that value chain. So how did things get funded back in the day? How was it that Iridium was able to raise money? How were some of these applications lit up? Was it an underlying government backing, or was it a particular moment in the financial system? What's your take on how things got funded back then and what's changed?
Well, so part of that whole thing was that companies bet their companies on it. Loral really bet the company on Globalstar. Motorola was a little bit more protected, but Motorola bet a tremendous amount on Iridium. Teledesic was really the birth child of Macaw, and probably but there was investing from Boeing. There was investing from what was called Alcatel at the day. There was a lot of Hughes, all sorts of Boeing. Who else was? There was a lot of companies, big companies, investing a lot of money in this space infrastructure back then. Alcatel did Skybridge. And yes, we did get equity funding, but that equity funding was coming from major aerospace businesses that really thought that the commercial market was burgeoning. And it backfired. It didn't work. Sure. Hey, thank you, everybody, for tolerating me.